All right, welcome back. Let's get started on the workshop sessions. I personally very excited about the hands-on workshop because here you can jump right into the code and follow the steps. I see many of them actually already got early started. That's great. So for this workshop, what we're going to do is we're going to develop an app with Gemini AI and also the Vertex. And we're going to build more using the writing code and build applications called the Gemini API, and also deployed run your applications on the cloud run. So it's a great way to learn. Before get started, the two things very important to do. The first one is make sure you join the Slack and or the Discord. Either way is fine. And the link is in your emails and also on I post on the YouTube comments. Make sure you join the Slack. We're going to do the live support over there, ask questions. And actually, a lot of questions already answered over there. Some of the instructions, step by step, everything is over there. So make sure you join the Slack or the Discord. And before to get started on the Code Lab, the Code Lab actually running on the Cloud Skill Boost, Google training website. This one is actually using the real the Google Cloud platform, and they have a time bounded. I think this lab is for 1 hour 30 minutes. You will, when you're running the lab, you actually connect with the Google Cloud platform. So the way they are running this one is many of the labs, they are you actually need to pay to run those labs. For today, since we're running the events, we have that credit to use you can run those labs for free. The first step to run this lab is to get the credit. Otherwise, you probably have to pay if you want to pay with your credit card for the credit. But here we have that link. You can use it to get a free credit, and you can run the lab. So the way to get the credit is again, the steps is in the Slack. So you need to follow that steps, exactly steps. You will get the credit. I think we have the 10 credit to run the lab should be sufficient. Sometimes if you follow the steps, you still did not showing the credit, you can either redo the steps. You can log out and log back in, and the credit will show up. Once you have the credit, you can start to run the lab. Remember, once you start the lab, the timing will start counting, and you cannot pause the lab. It have 1 hour and 30 minutes. You have to either finish the lab or time out. You cannot pause it. However, since we have more credit, you can run it again later on. And also with the credit later on, you can I think you have additional credit. If you see other code labs you are interested, you can try it out, you can run it, you can learn it at home. But you have to get the credit today. The link is in the emails or in the instructions. That link is going to expire I think by end of today. So you have to do it the first step today to get a credit, and then you can do the lab today or later. So if you already have the credit, you're ready to go, feel free to have a sum up either in the YouTube or in the Slack. Just let us know you are good to go, or you're already in the process. That's totally fine. Hey, remember, you can get started on the workshop if you want, and meanwhile, I will helping the those uh, attendees have, if they have questions, I will answer them. But you can get started. Go ahead.
Okay. So let me try to share my screen. Okay. So this is the Google Cloud skill boost we are going to work with. Develop an app with the Vertex AI Gemini Pro. This is free for everybody who is gonna use it today. So what we will do is that we are going to use the 1.0 model and also the 1.0 vision model, and we will go through a little bit difference of like what this compared to my previous example was, what's the difference here. But for the people who are joining now only for the lab, we'll first go with this. So first, what everybody will do is that press the start lab button. Once I press it, it starts something like this. It starts a countdown timer, which looks scary, but 1 hour 30 minutes, it's enough time. Then it produces me some other things. This is a cloud username, this cloud password, project ID. There is no point copying mine because you all will get your own. We will use this specific username, password, and project ID for our work. Do not use your own to do that. So what we do is that we press this button, open Google Cloud Console. That brings me to a login page. Let me copy the link, paste it, and share that tab instead. Wait, present, share screen, entire screen, share. Okay, so this is the one. If you still remember correctly, this was our Google Cloud username that was generated in the last page. I press next with it, and this is the password we got from the same page. We press with it, and we log in. Be very careful not to log in with your own username password, then otherwise it will be built with your own GCP. These are generated on the go, one-time usage for you so that you can do the lab today. So once I press I understand, this takes me in here. And I agree to terms and conditions. This is my country. This is the user. I agree and continue. Now, this is my Google Cloud Console. I have access to all these. This is the project info, quick labs, the project number, uh, the project ID, and everything. If you see here, this is the project. So we know we are in the right project. So we are not going to be built from something weird. And this is a student. This is the one we got created. If you see, the account is managed by Quick Labs, which is Google. So yeah. Now, what are our objective? So we will develop a Python application using the Streamlit framework. So you can follow along with me using the Google Cloud Skill Boost webpage you had opened before. So what we will do today is develop a Python app using Streamlit framework, install Vertex AI to work with this, develop a code which interacts with the 1.0 model and also the 1.0 vision model, and then containerize this whole application, deploy it, and test it on Cloud Run. If you have any questions, you can start putting them in and I will try to answer it. Okay, once we are in this stage, once you have logged in, if you follow the instructions, we need to activate the Cloud Shell. So Cloud Shell is a like virtual machine which we need to activate, which is this button. Let me make it a little bit bigger. Okay, so this button, this is activate Cloud Shell, and a bit more bigger. Yeah. So I press this, and I don't need this. So I get something like this: manage your infrastructure development, etc. Cloud Shell is free for all users. I continue with it. It's provisioning my Cloud Shell machine. Got it. Okay, so this is the Cloud Shell. This is essentially accessing the VM we have been assigned. So first we need to see all the active account names to again make sure we're in the right place. So I do gcloud auth list. You can see the same command in your Google Cloud Skill Boost instructions. Once I press this, I need to authorize Cloud Shell, and I get the correct account listed, and we can see if this is the same one as not. So I can say this is the same one, and we're in the right one. So we also need to see where is the right project. So again, gcloud config list project will show me the projects we are. So we are in the right project, the quick lab GCP, this one, which you can kind of see from here as well. So we are in the right one. Now we need to configure our environment and the project. To do that, we set the project ID and environment variables in Cloud Shell. You don't have to manually do that. Your Cloud Skill Boost page will already show this information. I am copying from my information and just pasting it here. So this is what my information should automatically populate. And when I press enter, it gets populated that your active configuration is Cloud Shell, Region West 1, and Quick Labs. So very good. Now we need to enable a couple of APIs which we can do manually. For example, the AI Platform API and Cloud Run API, but we can also use it with this nifty Cloud service. So let's see what we are enabling. We're enabling the Cloud Build API, the Cloud Functions API, which we will need, the Cloud Run, logging, so that we actually know what is going wrong, the storage app component to store our data, and of course the generative AI part. Once I press enter, actually I can probably maximize it. And maybe I can make it bigger. Oh, no, this is okay. So we can see it finished successfully. So we have it enabled. Once it is done, you can, so let me just drag this different window here. So all I have been doing till now is literally copy pasting commands from here. This is the command for enabling the region. This is the command for enabling the cloud services. Once you are also done with it, you should press check my progress. This will automatically check that if you have done this correctly, you will have something like this, the green tick like me, and the assessment should be completed. Now we set up the application environment. So you should have this window open. I have this window open, and you can just follow along with me. So here, we need to confirm the Cloud Shell is authorized. So we just do something like Cloud Shell, gcloud auth list. So it will check the authorization list, and we'll see that, yes, okay, we have that. And if it asks you to authorize the Cloud Shell, you should have a like small pop-up window like I had initially to authorize the Cloud Shell. Now let's make our first directory. So we can make a directory like Gemini app and press it, and the directory should be there. If I do a ls, I can see that Gemini app is there. Now we need to log into that directory. So I am in that directory right now. Now we are gonna use Python's virtual environment to create a VM environment for our application, so that any changes we do, any applications, any PIP libraries we install is part of that specific environment and not affecting our whole installation. This is very useful if you are creating multiple applications with different dependencies, and overall recommended practice. So what I do is that I run this command, which essentially creates a virtual environment named Gemini Streamlit, and press it. It will provision a couple of things. And here we are. Once it's done, we need to activate this environment. How we do that is literally run it the source Gemini did. Inside that, activate this, and now it's activated. How do we know? You will see this appended before your session. So now we know we are in a virtual environment. Now we need to install dependencies in this application. So for us, the dependencies are AI platform and cloud logging and Streamlit. To do that, we will create requirement.txt, and from that requirement.txt, we will actually just run it. So you can also do something like vim requirement.txt, or if you just want to follow the collab, then the cloud skill boost, then you just paste it. What it does is that it uses the cat command to create a txt file requirement.txt, and inside that you have these things. So once I run it, I see there's a requirement.txt, and if you want to see what's inside it, you see these are the things: Streamlit, Google Cloud, AI Platform, Google Cloud Login. If you want to have any more application libraries installed, you can just add something here and it will work. So we go out, our requirement.txt is working perfectly. Now we need to install these dependencies. So what this command does is that it tells pip, which is Python's package manager, to install anything that's in requirement.txt. Once we run it, so I see one question about points. The points are, so you will start with 0 points. So you will start with 0 points. The more you start going with, the more you start finishing up each of the requirements, you will start getting, oh, I don't have control over my thumbnail. Maybe, yeah, I cannot control my thumbnail. That's StreamYard, I think. Yes, that's better. Okay, now you can see everything. Okay, once you've done it, now we start creating the application. So how kind of the code lab goes through creating the application is literally using the cat command to build the whole thing. You can also do that, of course, which I just did, but you can also actually just copy paste and do that. But let's see what we did just right now. So this is the app.py, which got created using our cat command, and let's go through it step by step. So we import a couple of libraries. We import OS, Streamlit, and a couple of other things, including Vertex AI and the cloud logging. We configure the logging to specifically only towards the info, not anything else. And we have the project environment set with project ID and region. Remember, these we have configured beforehand. Now we load the models. We load the Gemini Pro and the Gemini Pro-vision model, and this is going to be the header of the Streamlit application, just Vertex AI Gemini API. And these are kind of the tabs. We'll have the story, marketing campaign, image playground, video playground. You can change any of these if you want. It will still show. So I can do something like, and it still should work. So once we see, okay, once we have seen what we have done, now we develop the story. So as you just saw, we have a story tab. So we have something to have inside the story tab to render something in the story tab. So we're gonna create something called app underscore tab one, and we'll have things under that. So if you follow skill boost, it's gonna ask you to use this cat command to have everything in one go, and it will create it for you. So now if we see, let's clear the screen. If you see, this is what we just created. So this is the generation prompt. We have a character name, we have a character type. The character name is Mittens, type is cat. We have a persona of that character, what the character personifies. Mitten is a very friendly cat. Then there's a location, length of the story, how long we or short we want it to be, and then certain things. So how it should be, sci-fi, fantasy, thriller. Then we have this creativity control. So some of you who are already playing with LLMs, then know what temperature is. I'll still explain very shortly. So what temperature is that it essentially is how creative your AI will be. So when I say creative, means that how each time you run it, how different, how wild its the probability distribution of the words will be. If you have it more, the temperature more, the more the varied distribution will be. The less less distribution will be. In short, if you have it very near to zero, you can put it zero. Technically it's never zero inside, actually inside in LLM, but if you put it very near to zero, every time you put the same prompt should get you the same answer. But anyway, let's go through the code. We have the length of the story, the prompt, the temperature, and everything. Okay, we are happy with it. We go out, and we also need to develop the responses. So that we do using this, the next command, which gives us the response utils.py. Let's also take a peek at that. This is what it does. So we import certain specific points from Vertex AI generative AI model. So we have content, generation, configuration, model, image, harm category, and everything. I will not go through all of them, but a very specific part of them, which we have not discussed in either our talk or here. What's that harm category? What's that harm block threshold? So remember, in my talk and the other talks we have discussed till now, there was always part of that responsible AI. So that's where the inbuilt guardrails and inbuilt harm detection comes in for Gemini. So you have these categories, these thresholds where the cat model can itself review itself and see what the responses is, how much harmful, how much abusive it can be. There are different categories of harm. So you can actually tell that, okay, this category I want, you can tolerate this much, but don't uh, tolerate anything, block all of them, or you can also have to, okay, block none. You will still get a wording that, okay, this is what I'm getting output, and you still cannot make it produce like harassed content. But these are extra guardrails you can put in. So you can see in the safety, we don't have any blocks right now available in the response. And this is essentially all the configurations we have. There are a lot of other configurations you can do, but this file will provide that. Once we are done with it, let's try to actually run the application. Let's clear the screen and let's run it. So what we do is that we run a Streamlit command, which tries to run this in our own machine. So which is for us is a cloud VM. So it will run in VM's own localhost in port 8080. This application, which will in the backend connects with all the 3 Python files we have. So once I run it, just run, and you can now view a Streamlit application in your browser. Don't open localhost 8080 because you will see nothing. So because see, if I try to open it, it opens this link. So this is not localhost 8080. This is a very different link. So don't try to open localhost 8080 because that's going to be your computer's localhost, not Cloud VMs. So if you want to see Cloud VM, you can either either do what I just did, press on this, and it will open this whole link for you. Or the correct way probably is you can see this here, the web preview. Once you click the web preview, you have an option like which port you want to see. So we have defined port as server 8080, so this works fine for us. But if you don't want, you can change the port. But anyway, we press this, and this is the application. So this is kind of, you can, I mean, both, you can use both, but this is the recommended way to do that. You will also see this way in the Cloud Skill Boost, not the way I just did. Now let's test our application. So enter the character name. These are the things we already have in our Python application. We can change them. So let's okay. So I think this works fine for us. We can live in Andromeda Galaxy. I wanted to be creative. Of course, sci-fi. Generate our story. And let's make it bigger. So as you can see, it has chapter by chapter story of everything. Now, if you are in this stage, you can just press the check my progress button in the skill boost, and it should check your, so what I just did, check my progress button, I just click, and the assessment is completed. So it will know if you have been able to create and play with the story. Once that's done, we can start playing with other things. You will see this one has other parts like marketing campaign, image playground, video playground. None of these is right now present. So let's start creating them. Let's close one of them. Okay, we are back. So this is where we can see the output of the server. So this is a local host. This is the output it just did. And let me just stop this. And okay, so we are stopping our server and we are back. Now, if this is actually not running right now, if I refresh it, it will go away. But this is our second tab, right? So second tab, third tab, fourth tab. So for the second tab, we need to create an app tab 2, which if you copy paste again, this is what you will get. And if I press enter, I have something called app underscore tab 2. So again, we see what's under that. No. Okay. So here what we have. So we have text-friendly model, generate your marketing campaign, and these are the specific prompts we already have inside the campaign. So it will use these as a boilerplate. We have the temperature, output tokens defined. So this should work. Now we also need to modify our entry point. So which is the initial app.py. So here, so we have the render story tab, right? So we also need to have another part where it will know that it is going to have the other part, from tab 2 what it should have. So we just add this and do the same thing again. Here we see what it added was just literally after what we had, we just add these two lines from app tab to import render marketing campaign tab, and with tab 2 just enter that same model. Once we have it, we can run the same command, which is streamlit run. It's running again. Let's see. Of course, because this was the previous one, and it's running in the same one. Okay. Now, if we go to marketing cap, this is now working. Previously, it was blank. Now we have a generated marketing campaign using Gemini Pro. So exactly what we have put in. Okay, we need an interesting product name. So okay, so this is electronics, target range 1825 is fine. Rural. Of course, we need sales. Humorous. Yeah, we don't have budget anyway. So let's create a campaign. Okay, so it's a revolutionary new line of portable solar powered electronic design. So you will see it created a target audience, campaign objective, product, campaign channel, most of the things you will probably need. So these are the prompts which we had defined in our application. This is what it's gonna use. This is exactly what it's using inside with our input to kind of to create the campaign. So use relevant KPI to measure performance, describe how we'll track the success, specify primary secondary goal of the campaign. So it tries to use these prompts to kind of generate this marketing campaign. Now let's go back to our skill post. Let's check my progress. Yep. And we have more points here. So we check our progress estimates complete. Now let's start playing with the image. Again, I go back, stop it, and start playing with tab 3. So we need tab 3 for this. So again, this should create a tab 3 for me. Clear. Yes. Okay. So app underscore tab 3. So which is this? So here you will see, let's do something interesting. We just want to see whatever we change here works or not. So these are where it's getting the images. These are already part of the Google Cloud bucket. So you take those images, we have these, and we'll work based on that. So, okay, I save this file. And we also need to have our responses added to it. So to do that, we create the responses utils file, which got created here. So what happened is that it literally will add responses after that. So let's see what it added. So previously we had only this definition, Gemini Pro text response. This is the text, the harm category and everything. Now we have something called Gemini Pro-vision responses. So you will see specific temperature set, maximum token, and defined how the vision will work. So we go out of it. We again need to modify our app entrance. So we open it. So up to here we had from app tab 2 render this. So we now need to add the same thing for tab 3. So this time I'm just manually adding it. So from app tab 3, image render image playground tab, and we need to save this file, which I did here. Once this is done, we again try to do the same thing. Okay, so we try to run the server and it should run. Again, refresh this page. Okay, if we go to image background, here are the things we have: the furniture recommendation, open instruction, ER diagram, math reasoning, they're not there. Furniture recommendation is here. You see, the changes we did is here. Good thing, the whole thing is imaginary. There is nothing called Gemma, and that's in the future. So this is the image of living room. These are the images we had in our code. And let's see if we want to, if we generate recommendation. That should not have happened. Okay, let me close this and run it again. Okay. Okay. So now it's running. If you also face something similar, you will also see there are a couple of errors you might face. One is obviously the one I just got, but if you see Google Cloud Skill Boost page, you will see it tells you about another error, which is if you this is error failed precondition. That literally means that all these we have these files, these buckets, these are being provisioned. It's not ready yet. The error I got is different. That's a permission error. But if you have it, just stop your application, run it again, and it will auto provision. You should not have a problem with that. So you see, we got the responses. This is chair, not suitable for the room, is suitable for the room, not suitable, is suitable. Let's see if that's true. This is a room, a white background, and all these. These are the three chairs we got. Not suitable. Bar stool does not match the other furniture. Is it true? Yes, this is a bar stool. It does not match other furniture. This one, I would say this matches. So yes, this is soft upholstery matches other furniture of the room. 3 is again, yeah, probably doesn't match. Yes, not suitable for the room, doesn't match. Is suitable for the room because of this. And yes, so this does work. So let us go back to our cloud skill post. It's developed, check my progress, and we have earned 10 more points. Now we analyze our image layout. So this was the output we were getting. Chair, this is all the output we just got. So let me stop it again. Now we again add more things to our tab 3 because we want the open instruction in that tab. So we just add it. It should be added. And it also passes open like an image to the open instruction tab. So let's run the server again. Refresh my page. So if we go to image playground, now we have the open instruction. This is the image of an open panel. The prompt is, how can I reset the clock on this application? So this is a clock which is visible. I want to know how it can be reset. Let's see what it does. So it can understand it and it will give me instructions step by step. So look at the clock button on the control panel. It's located on the right side of the panel below the kitchen timer button. So it tells me exactly where to look. Press and hold the clock button for 3 seconds. Clock will begin to flash. Use the number button to enter the correct number. Press clock button again to save the new time. So this is the instruction we got. And we check our progress. This is completed. Yes, you can use other images. You can use any other image you want. So this is just like to show you how you can work with it. After this code lab is done, you can just do it in your own machine. Just point it towards the API. Now we'll analyze ER diagrams and play with that. To do that, I can stop it. Now we need to pass it the ER diagram images, which we again add to our tab 3 by this. And again, we run the server, we refresh the page, image background, ER diagrams. Now this added the diagram, math reasoning still should be empty. Okay, so we need to document what's happening here. So for the prompt for it is document the entities and relationship in this in ER diagram, then we have the input image. Once we run it, so this diagram contains the following entities: category, vendor, item, sales, convenience store, county store. Is that true? We can see category, vendor name, item, convenience store, store. Okay, and the relationship between the entities are category can have many items, vendor can have many items. So we see it can understand what's in the text, but that's optical character recognition. What's not OCR is that it can understand the relationship between them based on the diagram, based on why it's being pointed and what's the relationship between them. That's the more interesting and more, I'd say, impressive part. So we see it can analyze your diagram. It's still, we don't know about math. So let's see what we can do about that. So let's add the math reasoning to the same app 3. I added just some of the math images, like just written, handwritten things. And then if we want to play with it, remember all of this we are showing you can do even more easily using a Google Colab if you want to just play with it. So image background, and we go to math reasoning. So this is an image we passed, the most beautiful equation, and we have an equation. So these are kind of the questions we are asking. Extract the formula. What is the symbol right before pi? What is this? Is this a famous formula? Does it have a name? So this is the format prompt we are using. Follow the instructions. Surround the expression with dollar. Use a table with row. So we specify a very specific format how to do that. So these are the instructions, and let's run it. Okay, so this is the formula we have extracted. Okay, it's mostly correct. This is supposed to be the not equal to sign. What is this? Simple let be pi is I. It's an imaginary unit, which is mathematical concept. Looks right to me. Is this famous formula? It's a famous formula. It's not Euler's identity, which is also correct. So it can recognize what's being said, what's there. Okay, so now we want to do and see and do the same thing with video. Before that, just follow along with me, check our progress. Okay, we are on right track. Then we generate the video playground. To do that, again, we first stop it and add the information on app 3. Okay, and here, if you see, we have app 3. So we now also need to add it to the entry point. This app, sorry, app tab 4 we just created, but we need to add this to your entry point. So this does not know what is in tab 4. So we shall do that. So I'm just gonna manually do that. You don't have to do it. You can just copy paste from the code lab. So we have app tab 4 and what to show in the 4. Okay, we save this file and time to test it again. So this was our command for testing the server and we run it. Okay, we refresh this page. Okay, and we go to video playground. Okay, now this has a video. These still are empty, but we have the description. The video is running. Now we want to generate a description of the video. So our prompt will be, what am I looking at? Where should I go to see it? Well, top 5 places like this. Let's see how it does with it. Let's go to this prompt. What am I looking at? I didn't ask where from this video was taken or anything like that, but it understood the context. The video is a drone shot of the harbor in Sky Turkey. The town is built on cliffside overlooking Mediterranean Sea, etc., etc., etc. Let's verify it. Like they say, trust but verify. Let's see if we can find that image. We cannot, but it looks similar. Okay, this was probably that part. Okay, and then the town is built on a cliffside overlooking Mediterranean Sea, water is crystal clear, etc., etc., etc. The can visit Calberting and Florida Germany Airport, taking bus or taxi to Paris. Other top places at least. Looks pretty good to me. Then let's go back here, stop it, and add other parts of the video. So we need to generate video tags. Imagine if you want to build an app where you have created, you are a content creator, you are creating your videos, don't want to think about video tags, you want to automatically generate. So what we do here is that we add things in that app tab 4 by this. So essentially what we just do is that pass it what is the video, provide 5 base tags. So we just added this, provide five base tags, and then we run it again, refresh. Okay, here we are. So video playground, now we have the video tags part. So this is a different video. Let's see what it does. It's a slow motion video. Somebody taking a picture. These are prompts. What is the video? What objects are in the video? What is the action in the video? Provide 5 base tags. Once we generate the video tag, okay, what is the question in the video? Man taking a picture with a table, picture of a table with a camera. There is a table, chair, vase, plant, candle, statue, and a camera. What is the action in the video? Man is taking a picture of the camera. Provide 5 base tags: photography, art, travel, nature, photographer. Looks reasonable to me. Now, what are the highlights if we want to have highlight of a video and also where it's taken? So let's go and add what we need for highlight. So in app tab 4, we are gonna add this. So we are send we'll send it towards a video, and then we just add a single thing, which is what is the profession, what is the comment the video used for, and what's exactly the highlight of this video. Once we do it, we run it. Video highlights. So let's look at the video. This is a train running. So why this video is important is that so you might have seen this video in Pixel's ad. This is showcasing a feature called Video Boost, which takes when you take a video with Pixel, and if you have this feature enabled, it will automatically use machine learning to do tonal mapping and have, I would say, a HDR mapped night video, which looks, trust me, awesome, at least in my phone. So this was the showcase video for that, and these are our prompts. What is the profession of the girl in video? I think she explained in the beginning. I'm a photographer in Tokyo. Which features of the photo phone are highlighted here? So these are not explicitly stated unless it's here. In low light, it activates night sight, etc. etc. Summarize the video in one paragraph and response it in a table. So let's run it. What is the profession? Photographer. What features the phone highlighted here? Night sight and video post. The video is about a photographer working street at night, testing on the pictures, night impressed with the quality and videos that she's able to see, which is pretty good from what I can see. One very interesting thing is that you will see throughout this video there is something going written here. Person shown is real pixel owner, paid by Google for this video. Showcases a feature. There are other things written there. Coming to Pixel Pro only, requires photo update, etc. These are not ingested, so the model actually knows what you are looking for. Okay, with that, we check our progress once again. We are right on track, and now we'll see if we can generate a video location for this. Let's go back here, stop it, and we again update the generation tab with this. So what we did is that we passed another new video, and what we said is that what is straight, what's nearest section. Let's run and see what the video is. We run it, we refresh. Go to video playground, video geolocation. That's a really video. So you'll see it's running a lot. Let's try to answer the question ourselves. Do you know which city is this? With what street is this? What intersection? So as humans, any of you can get that information from this video? If you can, I'll be happy to see it in the chat. So let's see. These are the prompts we have. Following questions. What is the video about? How do you know which city it is? What street? What nearest interaction? Let's go to the response. So a bus driving through a city in the street in rain, that we can get. By the street signs and buildings in the background, how do you know which city? Well, as a human, we should also do that, but I cannot read anything in the video. So what street it is? Wellington Street. What's the nearest intersection? Wellington Street and Bay Street. So that's the impressive part for me here, because it can do a optical character recognition to read the street address, which I, at least from this video quality, I cannot read. And then it uses its own information to say that what is the interaction near that. So that I would say pretty is impressive as a model. And we go back here, test our progress. And yes, we have done our progress. Now we need to deploy this app in Cloud Run. So we need to first specify, let's go back and stop it. So this was right now running from directly from Cloud Run. So as long as our VM is active, this is running. The moment I stopped it, there is no backend. This is not what is ideal. Also, this URL is not ideal for sharing to people. We want it to be active in a maybe permanent VM, which is costly, which we do not want, or we can have it in a cloud run, which is a serverless solution, which is much ideal for this. So let's make sure we're in the right directory. We are. So we're not gonna do anything with that. And let's verify our project and everything is correct. So yes, we are still in the quick lab, Europe region. And then we set the variables correct for our service and artifact by this, and this is set. Now we create a Docker repository for this to run this app, to deploy this app rather. So not this. Okay. Yes, we have the service name. Now we need to have the G-Cloud artifact repository. So create a repository based on that name and everything, and it will try to create one. So it's creating that request. It's waiting for the operation to complete. And it's created. Now we set up authentication for it. So authenticate our Docker instance. Okay, it has added the credential. Now we build our Docker file, which will be used to build this. So this is where just using cat to define our Docker file. What it essentially does is just tell that, okay, expose port 8080, copy our present directory, the server address is 00000, opens it to the whole internet, the Streamlit application endpoint, where it's starting from app.py, and before that, install all the requirements from requirements for the file. So our Docker file is created. We can actually see it. There is our Docker file. Now, to build the container image, we just run this command. So this we just pass it to create the image. Now it submits the command to build the image. It's creating the temporary archive. It's doing everything to run it. This will take some time. So until this is like keeps on happening, uh, Everyone has been able to follow. Is there any question? So math. So I see a question. Given the math demo was incorrect, after you train it more within that conversation, how do you save that training to do further inference? So there are a couple of ways to do it. First is that using any LLMs to kind of just do mathematical calculation probably is never going to be a good idea, because these are, imagine a prediction system. Math is not prediction. So what, if you want to have it to solve math, what you do, and Gemini supports it, is called something called tools and function calling. If you had attended my talk, the previous one, I had shared a GitHub repository which has uh, at least like 6 different code notebooks where you explain what is function calling, how to work with it. So you can actually use those to specify and work with specific tools, including calculators, to kind of do your actual math, and then ask LLM to do the reasoning. So that's one part to get a better answer. But if you're asking more about like, okay, I am giving input that, okay, this is wrong, do this, do this, do this, and how to have that conversation memory part of that. So there are, based on what LLM you're using, there are ways to achieve that. So if you are using Gemini 1.0 Pro model and you are using the mode multi-turn chat, then you can actually have that memory and it will remember that memory. If you're not using multi-turn chat and just passing it as each command, then you have to use frameworks like Llama Index, LangChain to kind of build your own agent memory. Meanwhile, we see our Docker image is getting pushed. Oh, so I see one question. What was the solution to the what problem in task 6 again? I just stopped my Streamlit instance in the Cloud Bash and I just restarted it again. And that worked for me. Okay, so it's finally done. We have our Docker instance created. Now let's deploy it in Cloud Run. So what we do here is that to do a gcloud run deploy service name, and we pass our whole Docker to that. Once we do it, the service is deployed and a URL should be generated. So it's deploying the service, routing the traffic, and it's creating a proper identity policy for the app to work. Do we have any more questions? So function calling does not save the context history. Function calling is literally asking the LLM to do a stuff, like do something in a very specific way. We don't like, this is kind of out of scope for today's lab, but in very short, imagine you want your LLM to output some information in a JSON format. So you can give it an example that, okay, this is how my JSON format looks like, output something in this format, and it will try to do that. Remember the try part. In production environment, you don't depend on tries. You have to be sure that it's the correct JSON format. That's where function calling comes in. You define functions just like normal Python functions. In the function, you get certain things, and you have the Python code do something. from the LLM, you ask very specific things, and the LLM knows if some very specific things are asked, it will go and run that Python function and work on that output. So that's essentially in a very high level what function calling is. For our use case, we can have a function which literally does mathematical calculations. So a Python function to do all the mathematical functions you might want it to, use the LLM to understand what the equation is, but to actually calculate it, call that function, get the output, pass it on to you. You get correct response every time. And in production, that's pretty important. So we see it has been deployed. We have a service URL ready for us. Let's try that. And it's running. So this is not dependent on this cloud machine anymore. You see there is no server running anyway. Now everything is here. It's not this. And let's see if it works. Generate my story. All the things are here. Now, you still need to add a Vertex API access to it because this is a code lab. This will be temporary for it. But this is how it will work. So once you have done with it, these are all the things you have. This is how you deploy this whole application. So once you have reached this stage, you are in this check your progress button. I can share this again. And if you have checked your progress, you will see everything is done. All the things, everything is complete, and you can end your lab. Now, before you end your lab, if you want to actually see how this application is working, then let's see this cloud editor is here, and this is our application. Let's give it some moment to run. Okay, then the video was more interesting. So let's go here. The prompts are here. Try to generate a response. Now this is running, trying to generate location information. Okay, we have the location information ready. We go back, see, yeah, this is not running. This is running directly running from here. If we go back here, marketing campaign, improve brand sentiment, a little more budget, serious general campaign. Okay, it works reasonably well. This is more serious than the last time and have a lot of things. Okay, so we have completed, we have managed to build an Streamlit application that writes a story for you, does marketing campaign, understands images and suggests good things for your room, does video playground, has math reasoning, open instruction, and everything you might want to play with. So that was our code lab. That concludes what we do today. Once you are in this stage, congratulations, you have deployed, you have done all these within 1 hour. And if you are done with it, and so you don't have to do it with me, so you can do it in your own pace. Once you click the end lab button, it will ask, and if I press end lab, I'm pretty satisfied. Congratulations, thanks for reviewing this lab. And we go to next. These are the resources you get from this lab. So you earn 100 points for completing the introductory lab. So that was all we had for today. I will also stop this, and okay, so here we see all the APIs, all the requests we did, and everything. You see, even with this, it's not that much. If you go to the API overview, these are the different services we used. If you see, we most used Vertex AI, which is because we were sending requests. We did the logging quite a bit because we were logging everything. These are all the things we used. With that, I think we are at the end of the session. So, do you have any questions or any other questions for me?
All right, thank you so much. That's tons of informations, and I hope not sure how the attendees following through all of the steps, and I did some of the questions, some errors, and in the Slack. What we can do is we're going to end the live stream very soon. But all of the information is in the Slack. So maybe uh, uh, for speakers, are you like in the Slack? I mean, if you like Slack,
Yeah,
maybe quickly go through some of them to see if you want to answer it right now, or if the attendees have other questions easy to answer or quickly, we can answer it right now.
yeah.
But we can have like more questions later on in the Slack.
Let me restart my Slack because somehow that space is not opening.
And meanwhile, for the folks on
Okay.
the bear with us for the whole events, and we thank you so much. Stay with us for the until the end. I hope you have a good learnings today with the tech talks and the workshops. Again, for the workshops, if you already have the credit, the 9 credit at the very beginning, you feel free to run this lab or the other lab as many times as you want. You can rewrite and retry. I know the first time have a lot of questions. You probably cannot finish it in the time, but you can run it again and again.